Welcome to Pre-Calculus, Graphs and Models. Okay, the first thing that we're going to look at is how to graph a function by plotting points and then graphing. So what we're going to do is you're going to work on those points and the y values, and then plot those points and graph the parabola. Pause while you're doing this and then hit play to check your answers with mine. And there are my plotted points, and there is the graph of my parabola. Tell you what, it's a lot harder to do on this recording than it is on the smartboard, at least drawing out that parabola. That was not easy. Alright, let's move along. Okay, we're going to do the same thing this time with a cubic function. Go ahead and pause it while you work on the points, plotting them, and then plotting the graph. Good luck plotting the graph. I know I'm going to need it. Alright, there you go. That's a nice cubic function there. There are your points. And there is your cubic function. Notice that it either goes, usually any odd number function where the exponent is an odd, the lead exponent is odd, it'll go to the negative infinity in one direction, either positive or negative x, and in the opposite direction for the positive x. Alright, let's move on. Okay, finding intercepts of y equals x cubed minus 9x. Hey, that looks really familiar. But this time we're going to use algebra to find it. So to find the x-intercepts, set y equal to 0 and solve for x. Alright, I'll let you do that right now. To find the x-intercepts, set y equal to 0, solve for x. Pause and get to work. Alright, after solving for x, you got x equals -3, 0, and 3. And if you look at your notes back at the last function that we graphed, it's the same function. So of course those are the x-intercepts. But now we need to make them look like points. So we need to make it -3, 0, 0, 0, and then 3, 0. Now to find the y-intercepts, set x equal to 0 and then solve for y. I'll let you do that. Make sure you put that in point form also. Pause now. Alright, so setting y equal to 0, we get x equal to 0, we get y equals 0. And then we already knew that anyway. Here are the three intercepts. 2 x-intercepts, 1 y-intercept. Okay, symmetry. Symmetry can be over the y-axis, over the x-axis, or over the origin. To find out any of these symmetries, to find it over the y-axis, replace x with -x and get the same equation. To find it symmetric about the x-axis, replace each y with -y and get the same result equation. And then for it to be symmetric over the origin, set both the x and the y to negatives, replace them, and then find out that you have the same equation. I will let you do all three of these examples, and then you can come back and check your work to make sure you did it correctly. I'm sure you did. And there you go. There is your work for checking symmetry about the x-axis, the y-axis, and the origin. And now let's see if you can recognize symmetry just by looking at the graphs and not the equations. Which of the followings have any symmetry at all? Go ahead and pause and at least give it a guess before I tell you the answers. Alright, if you identified b as a function that had symmetry, you are correct. It is symmetric about the y-axis, it's symmetric about the x-axis, and it is also symmetric about the origin, because if you rotated 180 degrees, it would land right on top of itself. D has symmetry about the origin, rotated 180 degrees, it'll land on top of itself. And H has symmetry about the y-axis. Moving right along. Alright, go ahead. Check for symmetry on all of these. Pause work. Play. Repeat. Rinse. Boy, oh boy, this is getting crazy. At least I think it is. This is so out of my comfort zone. Alright. Deuces. Alright, as you see, it is symmetric about the y-axis, about the x-axis, and about the origin. It's a beautiful, absolutely beautiful ellipse. Alright, move along. Okay, finding points of intersection. The way you can do that is either using linear combinations, also known as elimination, or you can use substitution depending on what the equations are. In this case, I think we're set up for eliminating the y because their signs are opposite. We need to get the coefficients having the same number but different signs. It looks like we're going to get those to be a 6 because that's the least common multiple of 2 and 3. Alright, I will let you work on both of these to find points of intersection for both systems of equations. Come back. Alright, in both cases, the point of intersection was 2, 0. Hope you got the same answers. This will conclude pre-calculus graphs and models. Goodbye.